Maria, open your mic and pray for us.
In the name of the Son and of the Holy Spirit. Almighty Father, we thank you for the gift of this day. We get it into our minds. We pray in the almighty name of our Father.
Amen.
Amen. In the name of the Father and of the Son and of the Holy Spirit.
Amen. Thank you, Maria. I wonder whether Maria can hear me well. I saw you had a little challenge with network, but I think we can still go. Today we are going to share something, like we said last time. We want to go ahead and share something to do with the circle. So I hope you're ready for the circle. I don't know whether you looked through, like I told you, I'm using Sadler. And you can read through and see. There's some work there. Someone had told us to send the work last time. I'm going to tell Mr. Kaziba to send our work. I'm sorry I didn't do that, but I'll do it this time. Okay. Having said that, can we now go straight away and do our circle? Hopefully you have that screen now. May I have someone read for us what the circle is? Can someone read for us what circle is? Any volunteer to read?
Let me read, teacher.
Claudio, go ahead.
The circle is defined as the locus of all points like P, X, and Y, which are equidistant from some given point. Let us say C into AB. Suppose that the distance of the points P from the given point C into AB is R.
Then what? Thank you, Claudio. So when we are looking at a circle, we are actually looking at, if you look at that diagram, C, whose coordinates are AB, is the center for our circle. Then any point that exists anywhere on that locus, somewhere here, that point there, it is equidistant from the what? Any given point is equidistant from the center of the circle, as long as it is on that, it is on the circle. That distance, all of us know, is what we call the radius of the circle, R, and the point C, whose coordinates are AB, is the center of the circle. P is any point on the circumference, XY, so it can be where it is, it can be in any other point position. It can be somewhere there, it can be elsewhere. This is another P, even this one. So any point on our circumference, take it to be our P. So that distance from P to the center is what we have called the radius. And we are saying for all the points on the circle, that distance will be equal. For all the points of the circle, that distance from the center to that point will be equal. So what happens? Can we get that distance PC or CP, whichever you call it? And I think we can. And if we can, what is it equal to? So that is our discussion this afternoon. So we can get that distance. Let me share somewhere where to write. We have our circle. And after that, we are looking at the distance from the point P, whose coordinates are x, y, to the point C, whose coordinates are AB. That distance PC is equal to R. So go back and see, how do we get the distance PC? We are to recall, how do we get that distance PC? So the distance PC if I had P to be that point somewhere, if this was our P, sorry about that. If this is our point P, whose coordinates are x, y, and this is C, the center, whose coordinates are AB, the distance PC is obtained when we obtain the horizontal distance from C to that point. What should I call that point? The horizontal distance from P to that point. Should I call this point A, for example? I can call this point A. So what is this horizontal distance? I want you to take a note that A has coordinate, the x coordinate as x, if it is on the same vertical distance as P. But at the same time, its y coordinate is the B, since it is on the same horizontal distance as what? As C. So what is the distance from C to A? Horizontally, if this is XC and this is A, this distance here is XC minus A. And what about the vertical distance? This is Y minus B. Now, using Pythagoras, the distance from C to P, if I square it, will be the horizontal distance x minus A, all of it squared, plus the vertical distance y minus B, all of it squared. And we are saying, but CP is our radius for the circle. Meaning, therefore, that distance CP, which is x minus A squared plus y minus B squared, will therefore be equal to the radius of the circle squared. This expression that we have gotten here gives us the equation of a circle whose center is AB and whose radius is R. So it is the equation of a circle, center AB and radius R. Can I hear from you if there's any question that you would want, something you would want to clarify here? The chance is yours, please. If you want to say something, can you use this time? Yes. If there's nothing that you're saying, then we can continue. So suppose the center has coordinates 0, 0, meaning that the center is the origin. Suppose our center for this circle has coordinates 0, 0, meaning that the center is the origin. What is the equation going to be? If the center of our circle is the origin whose coordinates are 0, 0, then it means that I am going to have x minus 0 all squared, also plus y minus 0 all squared being equal to the radius squared. This will give us, what is it going to give us? This will give us the fact that if you simplify, x minus 0 definitely is x. So this will give us x squared plus y squared equal to radius squared. So this equation here that I'm getting here is the equation of a circle, center 0, 0, radius r. So that is the equation of a circle, center 0, 0, center origin, and radius r. And it is coming from what we have just obtained up here. The equation of a circle, center 0, 0, radius r. That's our equation for this circle of ours. Okay, anyone wants to say something here? Okay. Is there anything that you want to compliment? Should we continue? Someone in the chat, what if we use the vector form? Okay, you can also use vector form if you so wish. But for our discussion, we are going to use the coordinates. And we have said a circle is a locus, is the locus of all points that are equidistant from some fixed point. The fixed point is our center, and the radius is the r in this case. Okay, so we can move on and have an example here. I don't know if you are ready for the example. We could have an example in this one. Yes, please.
Sorry to take you back. I'm lost. On the other triangle, how did you get the coordinates of A?
The coordinates of the point A.
Yes.
Oh, if you go back, you will notice that if points are on the same horizontal line, if points are on the same horizontal line, I think let me just use something fresh here. If I have this here as my axis, y-axis, then I have my x-axis, something there. What do you have to get to learn here? You learn here that if this is my x-axis, and this here is my y-axis, this is here is the origin definitely. Any points on the same horizontal line share the y coordinate. So this can be -1, 2, for example. Sorry, this can be -1, 2. This will be 0, 0, 2. This somewhere here will be 1, 2. And it doesn't matter where you continue, the y value, this is the line y equals to 2, and the y values for all the points there will be 2. So this is 2, 2. Somewhere here we have 3, 2, and so on and so forth, 4, 2, etc. So the y values on the same horizontal line have, the y values are the same. So come back here. What do you notice? This C and the A are on the same horizontal line. So the y value, which is B for C, will be the same y value for what? For A. In a similar way, if you have a vertical line, if I have a vertical line anywhere, the x values are the same. So if this is 2, 2, somewhere here you'll have 2, 2, 0. When you go up this side, you have 2, 3. You have 2, 4. So the x values are the same. You have 2, -1, and you'll have 2, -2. So on a vertical line, the x values are the same throughout. That is the idea that we are using in our case here. That when you look at our triangle, if this is vertical line AP, then the x values are the same. So if my P here has an x value as x, then even my A will have an x value that is equal to x. That is what I have used. That is what I have used. So that is what gives me the distances, that the x value here is x, the x value for C is A, then x minus A is the distance. The y value for P is y, the y value for A is B, then the y value there is y minus B. This thing of distances between 2 points you have done at all levels. I don't know whether you just crammed it, but if you did cram it, you can check yourself again and see what did you do then. And you find that we are still doing something similar. Okay, that was for that question. I hope I've answered you. I didn't get the person who asked, I'm sorry, but I hope I have answered. If you are not comfortable, you can still let me know. Yes, Dina. Dina, open your mic.
Okay, sir. For me, I was asking. So, I'm sorry I came in a little bit late. So the R squared is the hypotenuse?
Yes, the R squared is the hypotenuse, but what makes it, because we have said C is the center for our circle, and P is a point on the circumference. So if C is the center and P is the point on the circumference, then CP is our radius from the center to the circumference. And we chose to take that radius to be the point, the distance R. Dina, I want to encourage you when we have a meeting to come on time. It is just good manners. You come
Okay,
on
sir.
time. Okay. But I hope I have answered you.
Yes.
Good. Okay. Should we go ahead? So there are two things here that we are agreeing on. One, I want you to take a note of the equations for our circle. I have said that if if the center then is the 0, 0, and the radius is r, the equation of our circle will be written as. So I want you to, those are two things that I would want you to move on now with. If the center for our circle, if the center is 0, 0, and the radius is r, and the radius is r, then the equation of our circle, then the equation of the circle will therefore be x squared plus y squared is equal to r squared. That is something that is very important for us. So if you left this discussion this afternoon with that fact, you will have achieved one of our interests. And we have said in general, if the center has coordinates AB and still the radius is r, then the equation of that circle, then the equation of the circle will be, what is the equation going to be? It will be x minus a, all of it squared, plus y minus b, all of it squared, which is equal to the radius squared. So that is something that I would want us to take note of. Then we can use this now to look at our example. So what is our first example going to be? I could look at this. That is our first example. Someone who is ready, can you read for us?
It says, find the center and the radius of the circles with equations A, x minus 2 in 2 brackets squared plus y squared is equal to 25. And part B says x squared plus y squared minus 4x minus 2y.
Thank you very much, Joshua. Can I have someone take us through the first example? We are having can someone take us through our first example? Find the center for the circle with the equation x squared, x minus 2 squared, y squared is 25. X minus 2 squared, y squared is 25. What is the solution? What is the center? What is the center? Question, what does it look for? Saying find the center and the radius. So what is the center and what is the radius? Queen Patricia, thank you.
Okay, good afternoon, everyone. Part A, our equation, which has x minus compare that equation, the given equation, with the general equation of the circle of x minus a squared plus y, yeah, that one on the board. So when we do compare, we realize that our a value is 2 and our b is 0. Therefore, the center of the equation of the circle, the center of the circle will be 2, 0. Then if we do compare the r squared with 25, that means our radius will be 5. Radius will be 5.
Thank you very much, Queen. Queen is using comparisons here, and I want to think that each one of us was following very well. If you compare the x minus 2, actually, personally, what I will do is to equate this to 0. To equate that x minus 2 to 0, when you equate that x minus 2 to 0, you get x equals to 2. And when you take the y and equate it to 0, because it is the y squared, but the y, if you equate it to 0, you can take the square, you get y equals to 0 still, and you get the center as 2, 0. And then when you take the 25 to be our radius squared, our radius will be 5. Thank you, Queen. Now, in the same way, if someone came in to give you the center as 2, 0, and to give you the radius as 5 and asked for the equation of that circle, whose center is 0 and whose radius is 5, you should be able to get that. Good. We can go back, and when we go back, where do we go? We can go to the next question. Find the center and just a minute. Let me see if I can get this question so that we can copy it here. Just a minute. Okay, just give me a minute. Let's see if I can get the questions where they are and copy them here. Okay, I think I'm finally there. Where is the question? If you checked page 385, I have page 385 here with me. You check page 385. The question is telling us to okay. I think I'm close there. Okay. I want to see if we can copy it here so that we don't run. Who is writing on my screen? Okay, this is our equation for the circle. Sorry about a little delay, but I think we are now set. This is our equation for the circle. Can someone now use that one to get for us the center and the radius? Are you ready? Who is there? Use hand up. If you are ready, use your hand up. The equation of the circle is x squared plus y squared minus 4x minus 2y equals to 4. What is the center? And what are the coordinates of the center? And what is the radius of this circle? Yes, Ruth?
For that number, I think we shall compare with the equation of the circle, x squared plus y squared plus 2ax plus 2by plus c equals to 0.
Okay.
So we shall compare the equation.
Okay, go ahead.
Then
Mukisa,
we compare.
Mukisa, you are writing, Mukisa. You are writing on our screen, please. Can we behave? I have never seen this. Can we behave? Okay, go ahead. Ruth? Ruth, go ahead, please.
After us writing the equation of the circle, we shall take the coefficients.
Yes.
Yeah. So we shall compare 2a equaling it to -4. Then we get the value of a. Then
just a minute. So a is equal to, you are taking 2. Okay, you have written in the first place, you are comparing this with x squared plus y squared plus 2ax
plus 2by plus c.
C is equal to 0. Yeah. And you are comparing that 2ax is this one here, isn't it?
Yes.
So you said, can I write now? I'm ready.
So 2a equals to -4.
Equals to -4, which implies that?
So a is -2.
Our a is -2. And?
Then 2b equals to -2.
And the 2b, when you compare that term with this term here, you are saying 2b equals to?
-2.
-2. And so b equals to?
-1.
-1. So what is the a, what is the b?
That's the center.
So what is our center? Can you state our
The center has coordinates -2, -1.
-2, -1.
The center is -2, -1.
Okay, someone here is using, Ruth is using some knowledge that we may not have shared here, but it is also nice that we get that. Laudio, I get your solution here in the messages. Thank you. Okay, go ahead. Ruth, what is our radius? Ruth?
We can get the radius.
So
we can get the radius. So radius equals to?
Radius is?
Equals to square root of?
The square root of?
A squared
The radius is the square root of a squared
plus b squared
plus b squared
minus c.
minus c. The square root of the whole of that expression. I think I like this.
Yeah.
What does
Yes.
this get us to?
Then from the equation,
Yes.
so we can see that from the equation, value of c can tend to be -4.
C can be
So the
negative.
value of, so we shall have -2 squared
Why are you saying C is -4?
from the
Because
equation
you're writing
given.
this expression here as x squared
Because
plus y squared minus 4x minus 2y, and you're bringing the c here minus 4. So our c is -4. Okay, go ahead.
yes.
Everyone is following. I am also following. So what is our a?
-2.
So our a is -2.
When you square it,
So we get that -2 and square it.
yes,
Our b is,
-1 squared.
so we square it. Our c is -4. So what do we do here?
So we shall get the square root of that.
What is our c? What should I write for c?
So now just put +4.
I write a -4, isn't it?
Yes.
So which gives me 4 plus 1 plus 4.
Yeah.
Square root of the whole of that. And this will give me the square root of 9. And this will give me 3 units. So Ruth says that the radius is 3 units. Professor Tamari. Professor Tamari.
Master, I thought that we are supposed to compare the center with the -a, -f.
Okay. Professor Tamari is also coming up with something. Can you give it to us, Professor?
That as we are getting the center of this circle, we compare the tip. C will be -a, -f. So after getting the a as -2, when we bring it into the other negatives, it becomes a 2, and our b is now becoming, b is -1. If we bring in the other negative b, it becomes a 1. So the center becomes 2, 1.
Can you okay, your work is in form of a question, but let us first appreciate Ruth for her work. Ruth, thank you very much. Can you take us through, Professor Tamari, take us through what, from the beginning, what would you do so that we compare with Ruth's work? What would you do?
I use the general equation of a circle, which is x squared plus y squared
plus y squared
plus 2gx
plus 2bx 2g.
Yeah.
Sorry about that. Plus 2gx
plus 2fy
plus 2fy
plus c is equal to 0.
Equals to 0. Thank you.
Now I compare
with our equation, eh?
Yes.
Our equation was x squared plus y squared
minus 4x minus 2y. Then I bring in the minus
4. After bringing the 4 to this side, not so?
Yes.
Okay, go ahead.
So by comparison, I say that 2g equals to -4.
From comparison, the 2g is -4.
So g equals -2.
And this implies that Our G is -2.
Then again, by comparison, 2F equals to -2.
And the 2F is -2.
F equals -1.
And F is -1.
Then C equals to negative.
Then C
4.
C is -4.
So now if they tell us to get to the center.
So what is the center in terms of G and F?
Center is negative G, -F.
So in terms of G and F, the center is -G, -F. So meaning, this means
now,
that our center will therefore be
a 2, 1.
Negative of G is 2, negative of F is 1.
Is 1.
Thank you. We are now there. Ruth is doing exactly the same thing as what you are doing. You are using G, Ruth is using A. You are using F, Ruth is using B. Now the issue is on center. What is the center? What is our center supposed to be? That is all. Is our center AB? Ruth, can you go back and check our work? Or is our center -A, -B? That's where our debate is. Can we clear this? Because we are doing exactly the same thing. Can we clear this? Ruth, you have something to say, I can see. Say it. Yes, please. Ruth, what is our center? Is it AB or -A, -B?
I think I would take -A, -A, -B. Okay, I think the value we got doesn't actually doesn't actually make A negative, because the value of A is just shows A is a negative.
A is a negative, that is correct. B is also negative, that is correct. That's exactly what Professor Tamale is coming up with. But now we are saying, what is the center? Is it AB or -A, -B?
I think it's -A, -B.
You think it is -A, -B. If actually you took your center, if you took your center as -A, -B, that is when you'll get X minus a minus A, all of it squared, plus Y minus a minus B, all of it squared. And that is when you'll have X squared plus 2AX from squaring that. If you recall the general equation which you gave us, which was X squared plus Y squared plus 2AX plus 2BY. Those come from the fact that your center was negative. So we can clear that. Professor Tama is clearing it for us. The values on comparison are very okay. Both of us get the values correctly, but our center is -G, -A, or -A, -B, and that is what is giving us the center to be 2, 1. Professor Tamale, if you can, if you are still following, can you work out the radius? Tamale?
For the radius, we say that R equals to the square root of G squared plus F squared minus C.
R is the square root of
G squared
plus
F squared minus C.
So what are we going to get in this case?
We are going to get
G is okay, squared. Our F is okay. Oh, they are negatives.
But we put them in brackets.
But we square that negative. We square that negative. And
then minus 4.
minus 4. So you are in agreement here with the what we come up with.
Yes.
What Ruth gave us.
So r equals to the root of 9,
which is 3.
which gives us 3 units.
The square root has 2 values, but this being the radius, we are taking the positive value.
Yes.
Which is the distance. Thank you very much, Tamale. I'm grateful for that contribution. This is for someone who is using something that they already knew. I can see messages here. Sooner, I see a message and I think it has been worked on. What if I collected like terms for X and Y, then completed squares, then compared with the equation of the circle to the radius and center? That is Constance Margaret, and I want us to go there. Queen is saying the center is 2, 1, thank you. Ladio is saying the radius is 3, thank you. Joshua is saying thank you, Ruth. We thanked Ruth. Thank you, Joshua, for that. Appreciating Ruth. And also, Mutete Sam is saying the center is 2, 1. Good. Thank you for those compliments, for those contributions. Okay, Dennis is saying thanks. Very good. Can we go and clear this now for Margaret? Constance Margaret, I think. I don't. Was it Margaret? Can we clear this for Margaret? Margaret is saying, can we use our knowledge of today? Can we use the knowledge of this lesson? And I think I pick something from Margaret there. Using what we have studied today. Hey, Margaret, I like that. The equation of this is the equation of our circle, sorry about that. The equation of our circle has been given as x squared plus y squared minus 4x minus 2y is 4. So can we collect, I don't remember what you said, collect like terms for x. So we can write this as x squared, sorry. We can write this as x squared minus 4x. Then y squared minus 2y equals to 4. And she's saying, and complete squares. I now take you to something that you may have dodged at a certain time. And we are saying we are big guys, know those business of dodging. Can we complete squares? That's Margaret. Margaret, please come and help us how to complete squares. Margaret. Margaret, come and help us. And if you don't want to help us, please talk to us so that we know that you are not going to help us. Is Margaret around?
Yes.
I like that. Okay, can we hear from you? If you can, if you can't, no problem. Please talk to us.
So after completing squares, we shall have x minus 2 into bracket squared plus y minus 1 into bracket squared is equal to 4.
Thank you. Thank you very much. Now, Margaret is giving us something, if you are listening. X squared minus 4x, what is it? And Margaret is saying we are going to take x minus 2, all of it squared. Now, Margaret, you will take note, and everyone in class, that when we square x minus 2, we don't come back to the expression on the left-hand side. We don't come back here. No, that will not be true. We don't come back here when we square the x minus 2. When we square the x minus 2, how do we get x minus 2 in the first place? We are taking x and we are taking half of the coefficient of x, which is the -2. But after squaring, this should be able to give us x squared minus 4x plus that -2 is also squared. There's a term that is additional there. There is an additional term there. May I please call upon you to take it away. Take away this term when it comes to here. Subtract that -2 squared so that your expression gives you what you exactly have on the left-hand side. I hope I am making a point there. I would want you to take note there. To come back to x squared minus 4x, you must subtract that -2 squared. Then you will come back to x minus 4x. Then again, what about y squared? What about y squared minus 2y? Margaret, and anyone who can pick it on from Margaret, if someone is there, what is y squared minus 2y? Anyone can give us that? We are completing squares, class. Professor Tamale?
So that will be y minus 1.
Y minus 1.
Squared.
All of it squared.
Minus.
Take away.
-1 squared.
That -1 squared. The -1 that we are squaring is coming from somewhere there. Okay? Very good, Professor Tamale. So can we put these back into our expression and we see what our expression is going to be? Remember our expression. What was our expression? This here is our expression, which we have sorry about that. Something is disturbing me here. Okay, good. Okay, we wrote this expression and organized it and said, let's write it as x squared minus 4x. Let's write this as y squared minus 2y. And all this is 4. Now we are saying complete squares for that. And we have been given x squared. No. We have been given x minus 2. All of it squared minus a -2 squared plus y minus 1, all of it squared minus a -1 squared. And we are saying this is equal to 4. So to fully organize this in the form that we learned today, we are going to pick the x minus 2, all of it squared. We are going to pick the y minus 1, all of it squared. And we have a 4. This -2 squared is going to shift and go to the right-hand side. And when we bring it this way, it will be a plus. So we shall have a -2 squared, and we shall also add this other one here, which is a -1 squared. So finally, what are we coming up with? We are coming up with x minus 2, all of it squared, plus y minus 1, all of it squared, is equal When you simplify the left-hand side, can someone help us? 4 plus -2 squared plus -1 squared. What did we come up with?
It's 9.
It is 9. Thank you. And so from that now, we can compare and say, what is our center? Our center for this circle is yes, Dina?
The center is 2 and 1.
2, 1. We are comparing with our general equation. Someone talked about it, our general equation, x minus a squared plus y minus b squared, where we said the a and the b are the what? Equals to r squared. This we are comparing with the r squared. So this is equal to r squared. And someone said the a and b is the center. The a, b are the coordinates of the center. And what is our radius in this case? When we compare, our r squared is the 9, not so? Meaning that our radius will be the square root of 9, which is plus or minus 3. But this is radius and it is distance. And so Sam, open the mic. Mutete, can you open the mic and talk to us? Okay, Mutete may be having a few challenges, maybe network. Dina, once again.
It's 3.
So the radius is 3 units. Thank you very much. That is from today's lesson. Those ones who were comparing x squared plus 2gx plus 2fy already have an idea. Which idea they are bringing here? That is very good. But those who did not have an idea can also complete the square. And when they complete the square, we are saying you write it in that form of a general equation. And when you write it in that form, then you'll be able to compare and get the radius and also get the center of the circle. Okay, can I have questions here if they are there? If they are not there, then we can proceed. Any question? Dina, are you now asking a question? Or you never put down your hand as if you put it down? Dina? Lynette? Open the mic. Lynette? Esther? Oh, Lynette. Lynette is on. Yes, Lynette, go ahead. You have opened. Please say what you want to say.
I've just joined, so I would like to know the schedule of these lessons.
Lynette, you are so soft. Can you shout? I don't know what happens with your mic is not picking you very well.
Yeah, I've said I've just joined, so I would like to know the schedule for these lessons.
There's something that I can't hear from what you're saying.
I think she's saying she has just joined. Teacher.
Yes.
That she has just joined the lesson. I don't know what maybe she wants some clarification.
I would like to know, okay, the time at which the lesson normally starts and ends.
Okay, Lynette, I expect you to have a timetable. Because the timetable guides us, please make sure you get a timetable from the group. We start at 2, or it can change. You never can tell. So when you use your timetable, it will be able to guide you.
Thank you.
Okay, Queen Patricia, I appreciate the result. Lodio R is 3, thank you. Joshua, thank you. Mutete Sam 2-1 thinks it, oh, these ones I think I had read. The ones I'm reading now are the Kutos Cyprian, thank you. Mutete, half the coefficient, yes. Dina, that's awesome. I don't know what was awesome, Dina, but that is, I think you have nothing wrong there. Where is the negative ones coming from when completing squares? Someone had said half the coefficient. So Ashraf, you should be able to see when we are completing squares that -1. Ojirong, divide the coefficient of y, which is -2 by 2. Thank you. You're answering, Ashraf. When comparing y, do we get 2 and 1? I don't know whether I can answer that. I'm not getting it properly. Yeah. Sorry, I've just joined. That is Lynette, and you have been helped. Just follow the procedure. I don't know who you are answering, but anyway, the procedure of completing squares. Acham Dina. Thank you. I think that is what we have from the messages, and some are answering, others are asking, but I think they are all taken care of. Mutete Sam, you had something to say and we waited. Are you ready now? Can you open the mic? Mutete?
Yes. Yes, sir.
Go ahead.
Hello, sir.
Please go ahead.
Yeah, sir, I wanted to ask now. Yeah, now in the second step, in the second part, this one, the last one, yes. We don't get like, because the other side, C, A, B, C, those are, we don't get.
Oh, when we complete squares, we only compare with this expression here. We had this expression which was giving us the radius of the, which was giving us the equation of the circle. That expression. So we are just comparing there straight away, getting x is A and y is B as our center. And what we have on the right-hand side, which in this place is this one, as our radius squared. So we are not having the s squared, the square root, etc. This here is already taken care of. When you look at our work, we have actually written it here. We have written that s squared d plus b squared d minus what? We have written them somewhere there. They are there. So we shall have written them already. Okay. Good.
Okay, thank you, sir.
Okay. Can we now move on? If there are no other issues, I want us to continue. And where do we continue to? To the same thing that we are following. No problem. To the same thing. What is that? Look at our work here. That was the example. And when we come here, we are looking at intersection of a line and a circle. If there's someone who can see my screen, please read for us. Yes, Cyprian.
That is saying intersection of a line and a circle. Then they're saying consider a straight line y is equal to mx plus c, and the circle, opening bracket, x minus a close squared plus y minus b squared is equal to r squared. There are 3 possible situations. 1, the line cuts the circle in 2 distinct places, i.e., part of the line is of the circle. 2, the line touches the circle, i.e., the line is a tangent to the circle. The line neither No, that's it, the circle. Thank you, sir.
Thank you very much. Do I still remember the name? Thank you very much. What was the name?
Cyprian Kutosi.
Cyprian, sorry.
Yeah,
Kutosi, I'm
Cyprian.
sorry. Cyprian,
Okay.
thank you very much
You're welcome.
for taking us through. There are three possible situations here that we are coming up with if we consider a line and a circle. We are looking at, I can have my circle here. If this is my circle, I can have the first part is a line cutting the circle at two distinct places. Part of this line from here to here is actually the chord of the circle. So that is possible. We can also have another situation where we have a circle and the line simply touches it. The line simply touches a circle. In that case, this becomes a tangent. And we can also have another situation where we have a line and a circle. And the line never touches the circle. Just this kind of thing. So those are the three situations that we may have. Those are the three situations which we are looking at. Fiona Nyangoma? Fiona? Okay, we can continue. So that is one of those cases that we are looking at there. Those are the cases. So we are given an example here. Show that part of the line, that one, is a chord of the circle, that one, and find the length of this chord. Show that part of the line, that one, that's in the example. So I can pick this from here. Let me pick this from here. Sorry about that. No, I don't have it here, I think. Oop. Show that. Okay. So what I want us to think of is something like this here. Show that part of the line, 3y equals to that one, is a chord of the circle. X squared plus y squared minus 6x minus 2y minus 15 is 0. And find the length of this chord. So that is, oh, have I shared my screen? Sorry, I think I haven't.
Sir, we are not seeing anything.
I have just noted that. Okay, let me try and share. I've just noted that. Okay. Can you get my screen now?
Yes.
Okay. Can someone read for us?
It's in example 6. Show that part of the line 3y is equal to x plus 5 is a chord of the circle x squared plus y squared minus 6x minus 2y minus 15 is equal to 0, and find the length of this chord.
Sorry, I hadn't opened my mic. Ashraf, go ahead and talk to us. Ashraf? Yes, Ashraf. Can you hear me? I saw your hand up. Okay. Ashraf could be having issues of the network, eh? But our discussion was that if I have a circle here, this question here is, I have a circle. Then, for my line, for part of the line to be a chord, what does it mean? It means that when I solve simultaneously, I should have the two equations. I should have two distinct points. There's a point somewhere here. There's also a point somewhere there. So when I solve simultaneously, I should be able to come up with two distinct points where the line is what? Is circle. Nyangoma and this Zoom user, please watch because you interfere. Please make sure you mute. Nyangoma, you apologized and I thought you had taken note that you are, when you open the mic, you interfere with us. Okay. When you solve these simultaneously, can we see what we come up with? Anyone to lead us? May I have a volunteer leading us here? Do we have issues solving simultaneous equations? Okay, nobody is ready to take us. Please, you can make X the subject here. And after making it subject, we then can substitute it in the equation of the circle. I'm now waiting. Make X the subject, and then we substitute it in the equation of the circle. Is there anybody ready to take us? Yes, Professor Tamare.
Okay, Master, we are making X the subject. So X equals 3y minus 5.
Good.
That becomes our equation. So we have now substituting that X into the equation of the circle. So it becomes 3y minus 5.
Just a minute. So we are substituting this equation, the value of x in the equation of the circle, and we shall have, please go ahead.
3y minus 5.
Good.
All squared.
Good.
Plus y squared.
Good.
Minus 6 into
Good.
3y minus 5.
Good.
Minus 2y.
Correct.
Minus 15 equals to 0.
Good.
So now you find the value.
And we look for y. May I request that each one of us tries out in 2 minutes, and then you give me the feedback, what you have come up with. 2 minutes should be enough for us to have a result from this.
Yes, sir.
Okay, are you ready? Kutos, I can see you have opened your mic.
Yes,
Cyprian?
sir. Yes, yes. So
Okay,
may I have,
are you ready? Take
yes,
us through.
yes, sir. Yeah, I expanded that first bracket, and I just read the answer, sir.
No, expand with us. Let us go together.
Okay, which is 9y squared.
Good.
Minus 30y.
Good.
Plus 25.
Good.
Plus y squared.
Mm-hmm.
Minus 18y.
Go ahead.
Plus 30. Minus 2y. Minus 15 equal to 0.
Good.
Then
collect the like terms.
Collect the like terms whereby
anyone to take us from there. Can I have someone else take us from there?
Okay, master.
Do we have someone else? Yes, Patricia. Patricia?
Okay, from there, yeah. From there, we collect like terms, so we shall get 10y squared.
Good.
10y squared minus 50y.
Good.
Plus 40.
Plus 40. Which is equal to?
0.
To 0.
Then we
Thank you.
factorize.
I like that. What did you factorize out?
Okay, I got 2 brackets. Y minus 1 into y minus 4.
When you factorized, can you first realize or recognize the common factor here?
Yeah, divide 10.
Do you realize that there's a common factor, Patricia?
Yes, yes.
Can you reduce before you do any other thing?
Yeah, divide 10 on all the terms.
What are we going to get?
Y squared minus 5y plus 4 is equal to 0.
Equals to 0. Acham, I saw Acham somewhere. Can you take us on from there? Dina? Dina, are you ready? Okay, Mutesi. Mutete.
Felix.
Mutete. Andama. Do I have issues of network here? Andama? Open your mic, Andama. Andama. Can you open your mic? Ozie? I see very many people, but they are not opening their mics. What is the problem? Mubiru? Okay, Andama. Andama, I can see your mic is open now. Okay, I think there's an issue of network. You are not clear. Andama, you are not clear. I think it is network issues. Can I have Mubiru? Go ahead.
Okay, so from there, you can use the bulldozer, or we factorize out y.
Can we use factorization?
Hello.
Yes, Mubiru?
We use factorization method.
Yes. Mubiru, the floor is yours. Ozie?
When we use factorization method,
Good.
we have y squared
Yes.
minus y.
Good.
Minus 4y.
Go ahead.
Plus 4 equals 0.
Mm-hmm.
We factorize out y and it becomes y into y minus 1.
Okay. And finally?
We factorize out 4.
Negative 4.
And we
4.
get negative 4 into y minus 1.
Good. Okay, so we shall have
we shall have y minus 4 equals 0 and y minus 1 equals 0.
So we have y minus 1 into y minus 4, all of it equal to 0. So either y is 1 or y is equal to
4.
What else is y?
It is 4.
All y is equal to 4. Thank you very much. Okay, if you check what our question required us to do, our question was show that part of this line is a chord. The moment you take a note that the resulting quadratic equation has two distinctive values, then it means that the line and the curve intersect at two different points. And so that is enough to have shown. But then they're asking for find the length of the chord, and finding the length of the chord requires that you get those values, that is coordinates for the different points, which here we have called A and B. So when you have the coordinates for A and B, then you can go ahead and obtain the length of this chord. Because we have obtained the values of y, how do we obtain coordinates of A and coordinates of B? How do we obtain coordinates of A and also coordinates of B? Yes, Patricia?
Yeah, I think because we had made our x the subject.
Yes.
So we can substitute in for the value of y to get the values of x.
Good. What was our x?
X was equals to 3y minus 5.
3y minus 5. So when y is 1, what is x?
Negative 2.
Negative 2. Very good. And when y is 4, what is x?
7.
7. So what are the coordinates of our points?
Negative 2, 1.
One of them is negative 2, 1. I prefer that I take that as our A.
Then 7 and 4.
7, 4. I want that to be our B. So when we say find the length of the chord, and the length of the chord, our chord is the AB. That is the distance AB. Can we have someone guide us to how we get the distance AB? Find the length of the chord is finding distance AB. Can someone guide us on how we get the distance AB? Sam, I don't know whether your network will. Yes, go ahead.
Yeah, so there we shall need to put them and get the single value that is x1 plus x2 over 2. Then
Sam, you want us to
y1 plus y2 over 2.
x1 plus x2 over 2. When we add and divide by 2, what are we trying to find?
The midpoint. We are trying to find this, the midpoint.
The midpoint. And remember, this is not, I'm not asking for midpoint. I'm asking for the length of the chord AB. So how do we get the length? This is our A, which is negative 2, 1. And this is our B, which is the 7, 4. So what is the length of the chord? Henry?
I think the length of the chord will be given by the square root of.
Good.
x1 plus x1 minus x2 squared.
Okay, the length AB will be x1 minus x2, all this squared.
Plus y1 minus
y1
y2, the whole.
y2, all of it squared.
Then under the square root.
Under the square root. Can you feed in the results that we have? Henry, can you feed in the results that we have?
Okay, our x1 is 7 minus -2.
7 minus a -2, all of it squared plus
4 minus 1.
Minus 1, all of it squared under the square root. Please complete. What is 7 minus -2?
That is 9.
And when you square it, what do we get? 81 plus 81. Felix plus, what are we adding here? 3 is squared. Not squared. Then it becomes a 9. And the whole of it under the square root. So you will get the square root of 90. And what is the square root of 90? Square root 90, what is that? 9.4868. It is
9.4868.
9.4868. 9.4868. So if you give your result to 2 places of decimal, what will that be?
9.48. 9.49.
9.49 units. Good. Thank you very much. That is that. Do we have any question on this? Anything that is not clear? Okay, we can have our last part and call it a day. Any question? Okay, no question. I can see chats from Suna. Can see chats from Suna. Shadrach. Yes, Pedro. Then I can see Sam. Sam was only organizing our class. I can see the values there from John. I can see Lodio. I see, yes, Lodio corrects the value. That one. Sarko, someone is asking for the topic. Valerie, this is the F6 class. Yeah, Form 6. And finally, okay. Okay, when I look through, I think I have seen all the messages. Thank you very much. So can we now have our last bit for this lesson? Yes, Acham, you had a question?
Sir, I never understood because I said that show that. So I don't know how did we show that in that part that we did. Were we just supposed to get the values of X and Y, the coordinates?
Our conclusion at that point was here. I see your point. That the moment you see that you can obtain two values of Y, that means at a certain point where we had the two values of Y, the moment you see that you can obtain the two values of Y at this point, you can conclude here that the line cuts the circle because solving simultaneously gives us two distinct values of Y. That means that there are two different points where the line and the circle meet. And if the line and the circle are meeting at those two different points, then it means that part of the line is a chord to the circle. So it is at that point that you can draw your conclusion. Okay? Shalma? Achama, have I answered your question?
No?
What is the question?
So that is it. Then, sir, when I ask you to find the locus, is it the same as getting the length? Oh.
The locus is the equation. And if they say the locus of the circle, it is the equation of the circle. If they say the locus of the line, it's the equation of that line. So when they ask for the locus, it's actually the equation.
Okay, so like this number of 2014, they had already given the equation, then part C was saying find the locus of P.
The locus of?
Okay, like that given the equation, then also the equation of the lines. The first part was saying find the coordinates of A and B, then the other one was saying determine the center and radius of the cycle. Then C was saying find the locus of P.
Okay, there's a part there. What was that C? That is very important. The locus that you are finding, that is the equation that you should find. But what we could do is we can share that question when we meet again.
Okay, sir.
I'm ready to share the question with us.
Okay.
Okay, please. Shalma?
Teacher, I was asking for clarification on how to get the length. I didn't understand that part.
How to get the length?
Yes.
I don't remember who guided us on length. It was it Henry? I think. And it is one of the things that we started with when we were starting this lesson. And it was the reason why I had drawn this triangle here. That if you want the distance from A to B, then you will find this point somewhere here. And this will help you to find the horizontal distance, that one, the vertical distance here, and using Pythagoras helps you to get the length of AB. What I could ask is, can you get the coordinates of this C? And we said yes, because we said since C and B are on the same vertical line, then they share the X coordinate. So the X coordinate for C will be 7 because they're on the same vertical line. And we agreed that A and C are on the same horizontal line, and therefore they share the Y coordinate. So the Y coordinate for C is also 1. So if you want to get the length from A to C, since it is horizontal, you are subtracting the horizontal, the horizontal coordinates. So that is where Henry gave us 7 minus a minus 2. And if you want to get the vertical distance here, you are subtracting the vertical, the Y coordinates, and that is 4 minus 1. So this here gives you 3, and this here gives you 9, And using Pythagoras, you square this and add them, you get the length of AB. Does that answer your question, Shalma?
Yes, teacher, thank you very much.
Welcome. Mutete?
Sir, I wanted to inquire, can I compare this one to vectors? Because you are saying that line AB is equal to, like, if you want to get in vectors, if you want to get AB, you say OB minus OA, such that when you get those final is when now, because now vector, but they want length, and length, it is like a scalar. Now we get length by getting the magnitude of that.
If you know vectors, you can comfortably use the vector approach. There's nothing wrong with that. Go ahead and use the approach of vectors, and you will be there. So it is distance. It doesn't make it any difference.
Okay, sir.
It is distance between 2 points, and it is the ordinary stuff that we all know. This is stuff that you have covered even at all levels. So can you make a good grip of what you already have? Okay, so that's, you are comfortable. Okay, I want us to close. I wanted to close with our last example. And so if there are no more questions, then we could have our last example for this afternoon.
Yes, sir. Hello.
If you can see my screen, then can you please, can I get a volunteer to read for us the question?
I have not yet displayed.
Teacher, your screen is off.
Okay, you can't see my screen. Can you now see my screen?
Yes.
Okay, may I get a volunteer to read for us the question? Acham?
The question says, find the equation of Roman numeral 1.
No, before that, can you wait? May I request Muhindo and Lynette? Lynette, please close your mics. Muhindo and Lynette. Lynette, thank you. Muhindo, can you close your mic? Muhindo? Okay, go ahead.
The question says,
It was already muted.
Find the equation of the tangent and the circle with equation x squared plus y squared minus 6x minus 2y minus 3 is equal to 0. The points 5, 4 on the cycle.
Good. So we are interested in the equation of the tangent and the normal to the circle. The circle is given, and also at a point that is given to us. Okay? Okay. What are we going to do here? What are we going to do?
Screen is off, man.
So your screen is off again.
Okay, I'm going to share another screen where we are going to write.
I'm not seeing anything.
Okay, there we are. Can you now see my screen? Yeah.
Yes.
Okay. Someone read for us. We are finding the equation of the tangent and the equation of the normal to the circle at the point 5,4. What do we do? What do we do? Do you know how to obtain the equation of a tangent?
So let me try.
Good.
Like we are going to differentiate the equation so that we get the what? The gradients of the line.
Very good. We are going to differentiate so that we get the gradient function. It is not of the line, it is a curve. This is of this circle. Okay. What is the derivative? Our equation is x squared. Our equation is x squared plus y squared minus 6x minus 2y minus 3 equals to 0. Can we differentiate? Someone who is ready to lead us? Can we differentiate? Okay. Sam?
Yeah, so the derivative is 2x.
When we differentiate x squared, we get 2x. Very good. 2x.
Plus 2y dy
Plus
dx.
2y dy dx. Beautiful.
Minus 6.
Minus 6.
Minus 2 dy dx.
2 dy dx. Very good.
Equal to 0.
Equals to 0. This is something that we called implicit differentiation, implicit functions. So you differentiate each of the terms with respect to x. So even including the terms in y, differentiate them with respect to x, and you will obtain the gradient function for this curve. Collect terms of dy dx, this one and this one. So you are going to have 2y minus 2 dy dx, and this is equal to, please carry this to this side, the 6, carry it over to this side, and the 2x, carry it over to the right-hand side. When you carry the 6, it will change to positive and the 2x to negative. So what is dy dx finally?
dy dx equal to 6 minus 2x over 2y minus 2.
We can simplify.
dy dx.
I think it simplifies to 3 minus x out of y minus 1.
When you factorize out the 2, I like that. That's so beautiful. So we shall have dy dx. In this, when you factorize out the 2, will give 3 minus x out of 2 into y minus 1. I'll substitute because it was at the point 5,4, not so. So what is our dy dx at that point? Substitute the x and y values, and this will give us what? The 2 will go definitely. And we shall have 3 minus the x, which x is what?
It's 5.
It's 5.
5.
It will be negative 2 over 3, which is 2 over 3.
Y is 4. Sorry. Our y is 4.
It is 3 over.
So did you say negative what?
Negative 2 over negative 3, which is 2 over 3.
Where is the negative 3? Am I seeing
It's
properly?
negative. It's negative 2 over 3.
It's negative 2 over 3. The 3 is positive, not so?
Yeah.
So
Yes.
the negative 2 over 3 is the gradient of what? The negative 2 over 3 is gradient of?
Of the tangent.
Of the tangent. So to get the equation of the tangent, you will need this one point which we have, the 5, 4. Not so? And then the gradient of the tangent, which is negative 2 over 3. I am sure each one of us can use their knowledge and get the equation of that line. That is the equation of the tangent. Can someone talk about the normal? Can someone talk about the normal? Kilama? Kilama? Mutete? Queen?
Okay. The normal
Felix, you are giving us feedback.
The tangent, we can get gradient of the normal by saying that gradient tangent times that of the normal should give us a negative 1.
Gradient of normal. Come again.
Equals to. So we shall say M1 times M2 is equals to negative 1.
Okay. M1, M2 equals to negative 1. Sorry. M1, M2 is negative 1. Okay. So take the M1.
So the gradient for the tangent for the normal will not be 2.
So that of normal, if I call it M1, it will be the negative reciprocal, which is 3 out of 2, not so? So use the same thing. Yes. Use that gradient and also use the 0.54. So to get the equation of the normal, you are going to use 0.54 and the gradient, which is 3, 2, and you get the equation of the normal. Okay, I think with that we are going to stop there. I could leave you with a question to try, but I had requested that you get some work. No, I'll put it there, I think. Let me not give you any question. So that I get some exercise for you to try. I think that will be better. I want to thank you for the lesson. I want to thank you for sparing time and joining. Of course, we thank our parents who provided data. Please find time and appreciate the parents who give you the data. And I will want to tell you when we have to meet, let us keep time so that we avoid the issues of those who come in and say, I came in late, I don't know where we started, I don't know where to go.
This is Mr. Samuel going.
That is not good. Okay, if there are some questions, Ambrose?
Okay, thank you, sir.
Yes.
Like I heard you mentioning that those who have joined late, I'm actually one of them, but I was requesting like if you could send some of those notes so that I also access them from the WhatsApp group. I actually joined late.
I will.
Okay, thank you.
Teacher.
Yes, please.
Maybe your number. I want to request for your number. There's some paper I want to send today for market.
There is some. My number is on the group. You go to the group, to your group, class group, and you see Teacher Henry. My number is there. Felix?
Teacher, my question is, the other time we were using the AB, the other one of the students used the AB, then the other equation also had G and F. Now I'm worried, what should we use as we are attempting those questions?
Felix, there's no particular thing that is that we use. Someone uses AB and uses it properly, no problem. Use GF and use it properly, no problem. What I could say is that when you read Backhouse, you will find that G and F. I'm not so used to the Sadler, though I'm using Sadler now. When you use Sadler, but G and F is a standard that many times we use. Okay? Cyprian?
Yes, thanks.
Yes, madam. Now there is a came across whereby they can tell you they want you to find the value of maybe any letter. Then from there, if they give you like a point and then a circle, like this equation here, they said find the value of A. If the length of the tangent from the point 1 to the circle, x squared plus y squared minus 4x minus 6y plus 3a equal to 0 is 2 units. So how do you handle that one?
Okay, is it okay if when we meet again, we start with some of those questions?
All right, master.
Yes, please keep them safe so that when we meet, you come on time and present the questions so that we share as class.
Okay, thank you.
Okay. Wepukuru. Caleb?
So, for me, I was just asking for the timetable.
The timetable. You are not on the group? Wepukuru, are you on the group? Because the timetable is there. Your network is not very good.
But I never saw it.
No, you go back and look for it.
Okay, to check.
What I'm going to do is to share it again on the group,
okay,
so that you pick it from there. Okay, may I request for a volunteer to lead us in a closing prayer so that we close? Someone to lead us in a closing prayer? Yes, Dina?
Okay, let's humble ourselves and pray.
Dear loving Father, I want to say thank you for this day. We appreciate you for this lesson, oh God. It has been successful just because of you, Father. We say thank you for our dear teacher that you've enabled him to sacrifice his time and Lord to teach us, oh God, Father. We say thank you, Lord, Father, for his life, oh God. We appreciate you for the works of his hand, oh God. We pray that whatever thing that we've learned, oh God, may we, Lord, remember it, oh God. Let us not just learn it and forget it, but help us to remember it in every time of our life, oh God, Father. We pray that you bless him, bless the works of his hand, that next time as we are going to meet, oh God, we shall recall whatever thing he has taught us. We say thank you, we glorify your name, we surrender everything in your hands. In Jesus' name I pray and believe. Amen.
Amen.
Thank you.
Amen.
I want to wish each one of you a good evening and a nice day.